Fourth, we're going to look at the exterior wall allowable area of opening. There's a change in this requirement too. Now, to understand the change, we're going to look at the previous code and what the table told us before. Now, previously, the thresholds that determined the category of the allowable wall openings for exterior walls was based on certain dimensions. And these thresholds actually did not match another section of IBC, which is table 602, because the thresholds in that table, which was again thresholds for fire separation distance, were different than in this table. So the concern was, because the values in the table did not match another table within the same book, within the same code book, it created confusion when applying the separation distances that were equal on the threshold value. So the goal was to clarify the requirements that govern the allowable area of opening in exterior walls. So let's look at what changed in that table. So let's go to that table again. I'm going to enter the term exterior wall and also add allowable area. And I see that the IBC has 6 matches, so I'm going to click on the 2009 IBC. And again, I see quite a few chapters with matches, so I'm going to click on View All Matches Together. And I see that the top match is section 705 for exterior walls. Since I'm looking at exterior wall allowable area, I'm going to click on that. And I'm going to scroll down to find that table. And here in table 705, section 705.8 openings, I have the table. And I see that the thresholds have been changed. Now, previously, for example, this threshold used to be greater than 5 and equal to 10. Now it's been changed to 5 to less than 10. And although this might not seem very important, it provides uniformity across the code because these values, these thresholds, match the table 602, which are also which determine the fire resistance requirements for exterior walls based on the fire separation distance. So let's look at the overview. According to the 2009 IBC, the thresholds for fire separation distances are aligned between table 602 and table 705.8, and this will affect the allowable openings on the threshold values because now they fall into a different percentage category. So it is a fairly important change. Moving on to our last change, we're going to look at the firewall openings. In the previous code, the maximum allowed opening in a firewall was 120 square feet. There are, of course, exceptions to this requirement. However, the maximum was set as 120 square feet. Now, the concern with this requirement was that it was not consistent with the fire barrier opening limitations as specified in section 706.6. And in that section, the opening size limitations were increased in 2005 to reflect rolling steel fire door listing limitations that are used by the nationally recognized testing labs. So in 2005, the fire barrier opening limitations were increased. However, the firewall openings were left as is. So now we had this non-consistent condition And the goal with this change was to update the opening size requirements for firewalls based on the latest testing labs. So what changed? Let's again go to our eLibrary. And I'm going to enter firewall. And I'm going to add the keyword opening behind it to make the search more relevant. And I see the IBC 2009 with matches. And again, I see quite a lot of chapters with matches, so I'm going to click on View All Matches Together. And looking at the list of results, I see that the top one is Section 706 firewalls. So this is what should be the best result. And within the section for firewalls, as I scroll down, I'm going to go to Section 706.8, which provides information about opening requirements in firewalls. And here I see that the maximum limit for firewall openings has been increased from 120 square feet to 156 square feet. And again, as I said before, this matches the requirements, the allowable opening requirements, the limitations, I should say, for fire barriers. So again, back to our presentation, a quick overview. The maximum opening size in firewalls in 2009 IBC is increased to 156 square feet. So this is the change overview. Last, we're going to look at the fire-resistant joint systems and what the change is there. Now, previously, there were no requirements in the code for voids created at the intersection of exterior curtain walls and non-rated floor ceiling assemblies. Of course, there was a requirement to fill the void between rated, fire resistance rated floor ceiling assemblies intersection with the curtain wall. However, with non-rated assemblies, there was no requirement. So the concern was to prevent rapid spread of fire and smoke. Because history tells us in the first Interstate Bank Tower fire, which was one of the most devastating fires in Los Angeles, in the fire, the curtain wall perimeter played a highly effective role in spreading the fire. And although in the industry, it's common practice, even though if the perimeter is non-rated assembly, the common practice is to seal the void. Although it is common practice, the goal is to provide the requirements so that the inspection and the enforcement can be applied universally. So it's not left up to the individuals and professionals, the responsible professionals, but it is actually enforceable. So basically the goal is to seal voids in non-rated assemblies to achieve same type of protection required for penetrations through non-fire resistance rated floor assemblies.